using the rules. All right. Does the curve y equals x to the fourth minus 2x squared plus 2 have any horizontal tangent lines? Well, here's the whole key. Horizontal tangent lines occur where the slope, what's another word for slope? Or the derivative is 0. If the derivative is 0, that means you got a horizontal tangent line, correct? Because a horizontal line has a slope of 0. So in order to figure out what has a slope of 0, we need to figure out what expression represents a slope. So we just take the derivative. And because we are really good with our chain rule now, Zach, can you recall what that would be?
4x cubed.
Yes, 4x cubed. Minus, Lloyd, you know what the next term would be? 4x. Because remember, if we have 2x squared to recall, this comes out front, we multiply it, and then we subtract 1 afterward. 2 times 2 is 4, 2 minus 1 is 1, there you go. Because to do the lead term, if we have an x to the fourth, we talk about this 3 right here. Alright? This is technically a 1x to the fourth. I bring this down and I multiply the front by my exponent. 4 times 1 is 4. And then I always, when I'm done with that, have to subtract 1 from the exponent. 4 minus 1. That's where I get my 3. Always, always. So, Xavier, what's the derivative of 2? Thank you. So really, the derivative, my y prime, is 4x cubed minus 4x.
The derivative is always 0.
Of a constant. The derivative of any number is always 0. If there's no variable, the derivative is 0. Now, I gotta set that equal to 0 and solve. This is algebra 1 stuff. 4x cubed minus 4x equals 0. What's the first thing you think I should do? Factor out of what? Yeah, not only an x, but a 4x. When I do that, what do I have left? Minus 1. Minus 1. 4x divided by 4x is 1. So now I can do one of two things. Yeah, I can either factor that out or just solve it as it is and add 1 to both sides and take the square root. Or I can say that's x plus 1, x minus 1. What do you guys prefer? Factor that out one more time or solve it?
Solve it.
Okay, hold on. There are 2 ways we can do this. I can, and you can write whatever way you want it down. I can T-bone this right now and say for x equals 0 and x squared minus 1 equals 0. And then I solve for both of those. Well, this, obviously, x equals 0. That's 1 point on that graph where we'll have a horizontal tangent line. Okay. And the second place, or really second and third place, there's squares I'll get here, is if I add 1 to both sides, I get x squared equals 1, and then I take the square root. Correct? So what's my answer going to be? Plus or minus 1. So there are 3 spots there, at 0, 1, and negative 1, where that will have a horizontal tangent line. Now, we said there was another way, and people were saying this, yeah, that's a difference of squares. I could have said 4x, then factored this part out again to be x plus 1, x minus 1 equals 0. And then when I T-bone, I'm still going to get the same answers. This x will be 0, this will be negative 1, and that will be your positive 1. You still get your 3 spots, okay? Okay. All right, so we should have horizontal asymptotes at x equals 0, at x equals positive 1 and negative 1. So why don't we just check that? Just to make sure what we're doing makes sense. All right, so here comes the calculator, and I am going to graph the original equation before I get the derivative of it, which was x to the fourth. What else comes next? Minus 2x squared plus 2. If I graph this, I should have a horizontal line, tangent line, at 1, 0, and negative 1. So, let's take a look at this. Yeah. Here's negative 1, here's positive 1, and here's 0 on the x-axis. That's flat. It's definitely a horizontal tangent line there. That's flat. That's definitely a horizontal tangent line there. And that's flat. Definitely a horizontal tangent line. So it helps us get a visual of what the graph is actually going to look like for the function. All right, so problem 2. It says find the equation of the tangent line to the curve y equals x squared plus 3 over 2x. Now, before we found all these cool little rules for derivatives, we had to find f of x plus h minus f of x all over h. And I have to put x plus h in the numerator and square it, put x plus h in the denominator multiplied by 2. Then I have to subtract that whole, it would be a mess. But it's a good thing we have a shortcut for finding the derivatives involving quotients or fractions. And what was that saying that we had? It's low, d high, minus high. Yeah, I don't know. Let's talk about natural log earlier. And I guess I spell high L-I for natural log. Bam. No one caught that. It would have been candy, by the way. High, d low. Again. Draw a line and square below. Okay, that's just a little thing that came up with you weren't here, Tom. You'll get it. You'll get it on my previous video, which is on my YouTube page, Visca the Teacher. So, I hope you guys realize at this point, this is the high part, and this is the low part. All right? And we still use a chain rule to find the derivatives of the high and the low separately. So, let's do this. Low, that's 2x. Times the derivative of the high one. Well, what's the derivative of x squared plus 3? 2x. Yeah, and then it's 0, right? Derivative of 3 is 0, so it's just 2x. All right? Minus Zach Scott. Good job. Shout out to the Scott family. All right? So, subtract high, which is x squared plus 3, because that's my high value is, and the derivative of the low. What's the derivative of 2x? Not 0, because it's not just a 2. It's 2. It's 2. All over the bottom squared. So what's 2x squared? That would end up being 4x squared. Now we'll clean that up right now and put that. All right? So now, what's 2x times 2x up top? That's 4x squared. Minus, what do I get when I distribute this? In fact, let's do it this way. Let's put the negative with our 2. So let's just distribute a negative 2. So we can get rid of the parentheses as well. Does everybody understand that? Okay? And instead of distributing the 2 and then putting the signs of the negative afterward, I'm just going to do it all in one step. Okay? So negative 2 times x squared is negative 2x squared. And negative 2 times 3? All over. Because right in our problem here, we have to subtract the top. So what I'm doing is I'm combining this with this and then distributing. All right? So there we go. Now, if I wanted to, I can clean that up. I can clean that up even more. Let's clean that up. What do I do? Well, what can I do on the top? I can subtract these first. I could have divided up the 2 or subtracted these first. I was just going to simplify the top first. You could have taken a 2 out of everything. You could have. So that's going to give me 2x squared minus 6 over 4x squared. Now I'll take a 2 out of everything. There's less terms to take a 2 out of. That's all. That's the reason. 2 goes into here once. 2 goes into here 3 times. And 2 goes into here twice. So I've really got x squared minus 3 over 2. That is going to give me the derivative, which means at any point, I can find the derivative as long as I know what point. Good. Oh, yeah. I was thinking about canceling this, and then I left it out of the bottom, and I didn't. Ah! I should have paused that before you made that comment. So, dang it. I'm going to give you the pink one, which is the worst. I like the orange. So anyways, good catch, Tommy, because that would have been wrong for you to put that in there. All right, now, I can find the derivative of any point on this graph using this. But if I want to find what the derivative is at 0, I plug a 0 in here. But guess what? What would the derivative be if I plug a 0 in? It'd be undefined, which means either your vertical line, this can be derivative, corner, cost, maybe a jump, an asymptote, I don't know. What if I want to find the derivative at 2, where x is 2? It would be 2 squared minus 3 over 2 times 2 squared. 4 minus 3 is 1 over, 4 times 2 is 8, 1/8. So if we got to write the equation of the tangent line, right at this point, what's my x value here? 1. So all I got, you guys okay back there? This is at the point 1, 2, correct? So here's my x, there's my y. How do I find what the derivative is? Right at x is 1? I plug in a 1. So I plug in a 1 for my x here and my x here. I've got 1 squared minus 3 all over 2 times 1 squared. Negative 2 over 2. Negative 1 is your slope. Now, because we know point slope formula, this becomes real easy to do. Real easy to do. What is our point slope formula? It goes y minus y1 equals the slope of x minus x1. Let's just plug in. Right there. Here's our x. There's a y. Y minus 2 equals negative 1 x minus 1. If you want to be fancy, that's fine. I didn't have to write the negative 1. I could just put a negative sign in front of the parentheses. I could distribute that and then add over the 2. That's fine. But that's an equation. That's an equal sign, doesn't it? This is the equation of the line tangent to the graph right at the point 1, 2. If I wanted to do the y by itself, what would I do? What would that equation be? Well, I had to distribute the negative 1 first. And so I got y minus 2 equals negative x plus 1. And then I add 2 to both sides, right? So y equals negative x plus 3. That's also an equation. That's just slope intersection. All right, so here's the last and final slide of the lesson, and this is really just common sense. So, second and higher order derivatives. We know how to take the derivatives, but what about the second derivative of a function? All right, what do you think I do? I just take the derivative of the derivative. Okay, I take the derivative of the derivative, which is y prime, right? Or your first derivative. How about the first derivative? There you go. I know how to use a chain rule. On the second derivative, apply the chain rule again to the first derivative, or whatever rule it is. It's just to the process. That's it. Okay? And they have a different notation for that. This is the common one right here. Y double prime, or you'll see this a lot. That means just take the second derivative. Okay? That's all. These ones, I'll be honest, I hardly see them. This one was a big one, and this one is a big one. Those means second derivative. Those are means. Now, trick question. I'll give you another second to finish writing those down. What about the third derivative?
Do it again.
I just take the derivative of the second derivative. It is not a trick question. Sometimes in complicated math, you shouldn't complicate everything. Sometimes things are really just easy. Things. So how do you think I'm going to represent the third derivative like this? Yeah, I'll have 3 little apostrophes. Oh my God, look, there's 4 there.
What? Nonsense is this?
I don't know. But guess what? That was a double quote with a double quote, and it should be a double quote and a single quote. There should be 3. Okay? And again, this is the common form, or you'll see this is a big one right here. This one and this one are the most common ones. But if you got to write second derivative, just because I like writing less than more, I always used to write, like on papers, this and this, because they mean the same thing. All right? And I think that is it for this lesson.